Hi, I'm Sneha from HiEPIC, and today we will be talking to Leah and Matt from the UW iGEM team.
This is our media. These are all of our solutions. This is a PCR machine for amplifying DNA.
This is our main fridge. So this is where we keep all of our samples.
This is where we make all the media for growing our bacteria.
Our autoclave is shared between a few different labs from downstairs as well.
So why did you join iGEM?
Well, I think that I joined iGEM because it's a chance as an undergraduate student to get involved in research that you really wouldn't have an opportunity to see otherwise. And it's an interesting field because it merges both engineering and biology.
Tell us about some of iGEM's initiatives.
So iGEM is involved with a lot of different things. There's the design aspect of it, which involves designing a project from beginning to end, and researching all the components of that, and choosing which biobrick parts, which are like DNA Lego, to be used. We also have the wet lab, so we're in the wet lab right now, which is the lab implementation of all this stuff. We also do human practices / outreach, so a lot of educational activities for kids and the public, as well as examining an issue related to either legal or social or ethical aspects of synthetic biology. We also have a modeling team, which does the mathematical modeling for the design of the project, and software, which Matt's called.
Right, and the software team currently, our major initiative, is to try and build a biocompiler that will essentially, you'll be able to give it high-level design instructions, and it'll tell you at a low level what parts to assemble to give you a working biological machine of some sort.
And do you participate in any competitions?
We do. We always go to the Jamboree, which is the conference essentially held at MIT. But in addition to that conference, it's also a sort of a friendly competition, so all the teams go there and they present the work that they've done in the year, and then basically you just show your work, and then it's judged based on the relative merits of how far you've gotten. And it's a lot of fun because you get to see the work of people from all over the world. There's teams that come in from Japan and
What interests you about synthetic biology?
Okay, so I come from a systems design engineering background, which means that essentially what we do a lot in that program is look at, I guess, the key elements of engineering and try and abstract them to different fields. So biology is one of those fields that really hasn't had engineering applied to it before. I mean, existing biotechnology is really just randomly like throwing parts together and seeing what happens. Not even parts, just throwing bacteria together. So we're trying to change that.
Where we grow all of our bacteria. This one is the 37 degrees.
And what do you think is the potential for synthetic biology in the future?
I think that synthetic biology has enormous potential to expand. It's a really new field still, so I don't think we've seen a lot of what it can accomplish so far. So I think in the future you're going to see it expanding into fields such as manufacturing, health and medicine, environmental remediation, and many, many more.
Example of one application in one specific field?
Sure. So even at the iGEM competition, we see a lot of projects that could go on and become patented and be really successful in their respective industries.
What are some of the challenges that iGEM faces?
So as a science, synthetic biology is really new. So a lot of people don't know very much about it. So one thing that is challenging is getting the public perception to be positive towards it, just to teach them about synthetic biology so that they actually understand it rather than just forming negative prejudice against it. So that's where our outreach comes in. We really try and teach people so that synthetic biology has a positive perception.
Do you think that your academic life, provides you with the knowledge that you need to complete these projects?
Definitely. They're really complementary. So everything I'm learning in class, I can come and apply in the lab, and then I can actually learn the technical side of it. I mean, doing the hands-on stuff really helps enrich what I'm learning in the classroom.
What sorts of skills do you look for in potential recruits for iGEM?
Well, really the main thing is just being interested. If you are interested enough and if you want to do it, you can pick up those skills. I mean, I came in without any biology background really, but you learn it as you go along if you need to. Of course, it helps to have some background in either design or engineering or biology.
Tell us an epic story that happened to you while you've been a part of iGEM.
Well, my favorite part of iGEM is definitely the liquid nitrogen ice cream. So when the blueberries get fresh in the summer, we always make ice cream with liquid nitrogen, and it's really delicious and really fun because there's smoke of CO2 everywhere.
That's awesome.
It's pretty epic.
I'm Matt.
I'm Leah, and we're epic.